Hey guys, this is Nate Story with Bright Agritech, and today we're going to talk about RO filters. We're shooting this away from the filter right now because we're not talking about the teeny tiny little ones that you're usually going to put in on your farm. We're talking about some of the bigger models that you should be thinking about as you transition to bigger and bigger systems. So what we're going to do today is we're going to walk through how these systems work. And we're going to do it at a very large scale, but the principles are the same from big to small. So if you're using a small filter system, it's going to work almost the same way as the big one that we're going to walk through today. So if you have been thinking about an RO system, you probably have a problem with your source water. RO filters aren't necessary for every setup, but man, they are sure a great thing when you're trying to take really low quality source water and make it higher quality. So RO filters are short for reverse osmosis filters. Essentially it's a membrane, and a pump forces water through this membrane that acts as a kind of filter at a molecular level and is sorting out a lot of these, basically almost all of these molecules out of the water. So water can fit through these tiny pores in the membrane, but carbonates and other dissolved solids cannot. And so what you end up with on one side of the membrane is a really, really pure water. Now, that's a great thing for folks that have trouble with their source water. Not everyone needs an RO filter, but for most folks out there, if you're trying to start from scratch and have complete control over your plant nutrition, over your system solution, an RO filter is a really, really useful thing to have. So RO filters are very, very useful. The drawbacks are that they can tend to be a little expensive, so they cost you money. And then, of course, you always have to change the filters out. So you're gonna have to calculate this into your operating expenses, changing out those filters, those membranes in the long term, and making sure that you keep your water clean and your pumps operating efficiently. So that being said, let's go on in and let's look at this. I'm going to explain to you guys how it all works, and hopefully you can walk away from this video with a really nice, clear understanding of what RO filters are and how they work. All right, so we're inside now. We're in front of the RO filter. So this is a big Siemens RO filter, and water comes in. It goes through an initial pre-filter, comes around through this copper tubing, and goes into this big sand filter right here. So the purpose of the pre-filter and the sand filter is just to remove all of the big solids that we can filter out really, really cheaply with a minimal loss in water pressure. So the water comes through, comes in, and actually will then go through another filter right here, and then go into the pump that charges the RO system. So the RO system is charged with this big pump. This is the pump that gives the system a lot of pressure. It pumps water up out of here, and let's see, where do we come out at? So we're coming up, we're coming through here, and we're going into, back here, our RO membrane filter. So it comes out of the pump, up, and into our filters in the back here. So you guys will see that these filters are both in series and in parallel. They're all connected, so water can flow between them and equalize pressure across all of the filters. But each one individually feeds the tank. So the water is charged here. It comes out right down here through this high pressure tubing, comes up through this pipe, back through this high pressure pipe back here into these RO filters in the back. So these are the filters themselves, and water flows from one of these to the other. These are in series, but the water that comes off of them, the effluent, is in parallel. So each one of these has a high pressure tube coming out and feeding through this manifold here, the main tank. So this flows through here, comes back over this way, drops down, around, comes up, and eventually makes its way through that gray tube there over into the main tank. So the point really of this is to flow up through here into the holding tank. So the goal there is, because water demand is big volumes all of a sudden when you're, like, say, watering a greenhouse or topping off a tank, something like that, this system should be running fairly constantly and topping this tank off. And then this tank will be fluctuating up and down depending on water demand. So this is basically our buffer, our volume buffer. This gives us a little bit of room to draw it way down and then fill it back up overnight, or when the water use is relatively low. And the system can just be churning away at fairly low volumes, but a steady production rate. These systems can be back flushed, and most of them come with some type of back flushing option. In these, at the very end, because we said that all those filters are in series, right? At the very end, there's a hose that runs from the last filter back up through here and basically drains to waste, right? Just goes straight to the drain. And what that allows us to do is open up a valve, it's on a solenoid, and have water flow out of the filters back there, and basically pump it up and dump it down the drain. And what that does is it takes all the solids and rinses them off of the membrane, and then flushes them to the drain. So we can do some level of automated back flush on these types of systems, although you will have to replace those membranes fairly consistently. So that is definitely part of the operating expenses of these types of systems. You can see here on the maintenance sheet what this is coming in at. So this is, basically the percent of rejection, the efficiency of the system. But we're over here. Let's see, where are we? Yep, parts per million. So this is the ppm of the incoming water. We've got very hard water here in Laramie. So we're running as high as the 400s on water hardness and dissolved solids and salts and all of these different things, right? So it goes in, and what it comes out at, this is the ppm of the solution that comes out. So you can see we take that from, in some instances, almost 430 parts per million down to 5.8 parts per million. That is practically pure water, and it's amazing how fine these things can filter. So you can see what that does for giving you complete control over your water. Now the thing to remember is that if you're using this, you're removing a lot of trace elements, which means that a lot of the stuff that you rely on that you just never really count because it's just always there is now gone. It gives you more control, but it also means you need to pay more attention to your nutrients. So we just walked through that system in there, and I wanted to take a few seconds to just talk about scale really fast and when it's useful to you guys. So we just walked through a really, really big system. You do not need a big system like that, especially with a very small farm. So that's a pretty large system for a pretty large farm. But if you're operating a smaller farm, there are tons of very small RO units on the market that will work very well for you. The other thing to know is that I don't typically recommend RO filters until you're breaking the 200 to 250 parts per million mark when it comes to TDS or EC measurements. So you're measuring your incoming water and your TDS measurement on it is somewhere around 250 parts per million. That's the point where it starts to really eat into basically what you can dose your solution at. So we have farmers, their EC measurement might be in the 200, 250 range before they dose it with anything. And what that means is that they become much more limited on the amount of nutrition they can get into their water for their plants to take up, just because their source water has already got some salinity or some TDS to it. All right, well, thank you guys so much for watching. Again, we've got a lot more videos coming out on similar subjects, hopefully a little bit more the nitty-gritty for you guys, as you have requested. For more information, make sure you're checking out the blog, leave us comments, and as always, please subscribe.